implementation of the artificial intelligence and simulation logic. So much faster compute time now. And at the beginning of this project, we thought, well, if we can get it under 15 minutes, we'll be in good shape. So we're quite pleased with the performance now. So it's publishing, so it just generated all that information, and now it's publishing it to GIS data services, and we see that it says succeeded. So we have a green message at the bottom. It took 2.5 minutes. So now we can click the view that we just created. So before we start looking at the results of our simulation that we just all created, let's look at this interface. This is a new interface for you. This is a Flex application. So Flex is, it's an Adobe Flash-based product, or it's an Adobe product. Esri has been pushing it, and a lot of common operating pictures are migrating towards it, or are utilizing it. It has tight integration with the Esri GIS tools in the back end. It's Viper. I'm sure you all are familiar with Viper. It is based on the same things that Viper is based on, the same programming environment. It's based on the same programming environment that we built the West Virginia Common Operating Picture on. That is a separate project from this, but it's all utilizing the same type of development environment and tool set so that these things could then be integrated. So let's look. We've got, on the left-hand side, we've got an information pane, and that gives us, at the top, it says general information. So we can see that we've named this FEMA demo, and we say that there's 2 million people and four people per vehicle. So that's just the name and the description. We can click on this People tab, and we can see that we have 2 million people, 1% seeking minor, 1% seeking major medical. We can go down to vehicles. So here we can see all of the information based on, or all of the user input parameters that influenced or drove this simulation outcome. Okay, so we can look at simulate congestion, we can water consumption, all of those scenario parameters that we just painstakingly went down through and put in. Well, you can reference them here within your sim. Okay, all the way down to barrier costs down at the bottom. So now, what we look at here is the consequence management widget. And that consequence management widget, we can turn on and off different layers. So we can turn on and off our gas station, hospitals, urgent cares, shelters, the road network, and the water consumption, the water maps. So right now you don't see anything other than just this green road network in the back end, or the background, overlaid on top of a base map. So up on the top right, we have live layers so that we can pull in other base maps or other overlays that we want to put into the simulation. It doesn't affect the simulation logic, but it gives the end user better sense of where our critical infrastructure, if I needed additional resources. Like let's pull up the emergency operations centers. So the EOCs. So click that. So there, you see the icons came up on the map. So we have other data sets that we can fuse into here and overlay those data sets within our simulation environment. So let's go ahead and turn those off. But there's public health, military. There's a whole variety of them that we actually just plucked those from our West Virginia Common Operating Picture that we've been developing as well. All right, so now we can look at aerial, streets, or topo. So if we click on topo, we can get a different view. Click on aerial, we can get a different view. So whatever base maps you'd like to use. So then if we look at our consequence management widget, that's this black toolbox that's floating here over top of some of our counties. We see that it says dash days, dash hours, and dash minutes. So this is pre-event. The event has not yet happened. So we have something called time aware that we're utilizing, and that allows us to see the events unfold over simulated time. Some things to consider here is that we're going to see the road networks change color. We're going to see that change in color because of the congestion or the volume of traffic on those road segments or those road networks. You're going to see resources change colors based on resource consumption. So what we're going to do is just ease into this. So we're going to go one timestamp over. So now this is at the event. So right now there's nobody coming into the state. At timestamp 0, the cars are queuing up outside of the state. But we see that our hospitals are already red. So why are our hospitals red? So let's look at the legend. So here we can see we have a legend here. Our hospitals, the capacity remaining is 60%. Well, if you recall, we had set the hospitals to 40% beds availability. So right off the bat, our hospitals are already in bad shape. And that's before anybody comes into the state. So now, let's tick it forward 10 minutes. If we turn off some of these layers here, we can actually see what's going on. Then we'll turn these layers back on, but I want to show you the road networks. So as 10 minutes into the simulation, and keep in mind that congestion modeling is turned off right now. This simulation does not have congestion modeling, meaning that there's no limitation for the number of vehicles that can squeeze onto a road. You can have way too many cars squeezed onto these road networks for the parameters that we use for this sim, but we want to demonstrate to you first that there is an option between the two. So 10 minutes into it, let's do another 10 minutes. So now we start seeing our road network congestion spreading out. We've got our cars that are traveling to different destinations. Let's pull on our shelters and our gas stations, hospitals. Let's start turning some layers on. So now, if we look here, our urgent cares are getting hammered pretty bad. Our urgent cares, remember, 1% of those 2 million people need urgent care treatment. So let's look at this red urgent care and find information out about that particular facility. So here we see the name of it, First Priority Medical Choice. It was provided via NAVTech. We can see, where it's located, telephone numbers, etc. Let's look at the resource consumption information tab. So over the course of this simulation, we can see that at 0 minutes, this facility had a peak capacity that it could treat of 600 wounded. 10 minutes into it, it's treated, 16 people, and so on and so on. I don't want to put my math skills on the spot right now, but you can see that there's fewer capacity remaining as the simulation unfolds, of which in this case, with no congestion modeling turned on, it takes an hour and 40 minutes before it's depleted. All right, so now, if we look down here in the bottom right, we can export this table out as comma separated value or XML, so then you can load that into your Excel spreadsheets or favorite spreadsheet tool. So let's close this down. So that's just that one medical facility. So we can look at a gas station, see if there's any fuel consumption yet. Our cars may not need gas because really this is a small area of interest. Yeah, so cars don't need gas at this particular station. They're coming in with 3/4 of a tank, and they don't need gas until half a tank. Well, based on our fuel economy information we put in, it looks like we made some judgments that we have cars that aren't consuming fuel for these gas stations here in the middle. So then you could go in and you could retweak this sim and say, well, I want to adjust my fuel consumption information. So maybe I would want to lower my miles per gallon. So we'll show you that here in a little bit. Okay, so now we have some shelters here, and these shelters are not activated. So let's zoom out some just so we can get a total sense of what we're looking at. So we see that we've got our shelters here, we've got a road network that's coming in, and we've got high congestion on 81, and then behind our consequence management tool, we've also got a lot of congestion over in the Hampshire County area. Okay, so now let's activate some shelters. So on 81, it looks like we've got a very high amount of traffic coming through there. So we're going to need to activate a shelter. So let's activate this shelter here. But before we do that, let's pull up our war chest item. So remember our war chest. That's what we said we had in our inventory. That's what we have to work with, period. So if we want to activate this shelter, and we're in a post-impact situation, let's look to see the capacity of this particular shelter. So post-impact is 221. So that means there's 221 individuals at that particular shelter if we activate it. So let's look to see what our shelter base cost is and our shelter cost per occupant. So our base cost, right off the bat, we're gonna consume 10 cots, 2 radios, 10 MREs, and 5 volunteers. And then for this cost per occupant, we have 1 cot and 3 MREs. So I'm going to say, as the emergency manager or the person in charge of this event, I'm going to say, let's activate that shelter. Now, notice in your war chest items, you just lost resources. You just activated a shelter. It consumed those resources. So then what it does is it enforces you to, as David says, consequence management. Make sure that there are consequences to the decisions made here. So let's activate another shelter. Let's activate this one up here on 11. So it's our evac is 1620, our post-impact is 810. So let's activate that one. So once again, it's deducted from our global war chest. Okay? Now, what timestamp are we on? Let's see what timestamp we're on. So these shelters are now going to activate 50 minutes into it. So we can see that we have activated 2 shelters, and they activate 50 minutes into the simulation. And how do we know that they activate 50 minutes into the simulation? Because on our time slider, you can see that we are 50 minutes into it. So we just activated those shelters at 50 minutes. So let's back out. And let's look at our water consumption. So we've got a water consumption pane up here. So for those 4 counties, we can see what the overall water usage is. So let's look at Berkeley County's water usage. So Berkeley County's production